Well, this one includes a little bit of something for everybody. We have three pieces we're going to look at here. One piece is the cylinder, second piece is the cone, third piece is the half sphere on the end. Now, we're going to start off with the cylinder, dealing with volume. Volume of that cylinder is going to start out with the area of a base. The base is this circle here. Can anybody tell me what the radius of that circle is? 4. Where do you get 4 from? Perfect. It's 4 from there to there. So 20 minus 16 gives us 4. So it has to be 4 inches in every direction. Nope, that's just half a cylinder. So it's just going from the equator of the cylinder out to the edge. So that area is pi times 4 squared, otherwise known as 50.24 inches squared. That one might get used again later, by the way. So then the volume of our little cylinder, 50.24 square inches times 16 inches, which is 803.84 inches cubed. So that's our first piece. Our second piece being the cone over there. We have the same area of the base. So the volume is 50.24 inches squared times, what's its height? Careful. 9 inches, right? 25 minus 16. So times 9 inches. Divided by 3, which would give us 150.72 inches cubed. That's part 2. Part 3 is the half sphere. That volume is going to go off all on its own. That's 4/3 times pi times 4 cubed divided by 2 because it is a half a sphere. So 4 divided by 3 times pi times 4 to the power of 3. 133.97. Now we have those 3 volumes. To get the total volume, it is addition. Bless you. So I get 1,088.53 cubic inches for our total volume. For surface area here, we've got to take some stock of what we're seeing in spots here. First, for the cylinder, for piece 1, is the area of the base exposed at all? No, so the area of the bases are not on the surface. So all we're dealing with is a lateral area there. Of course, that lateral area involves us to know the perimeter of the base, which is just the circumference of the circle, which is pi times 8, not squared, just 8, pi times diameter, 25.12 inches. Which gives us a lateral area up here of that 25.12 inch perimeter of the base times 16, which is 401.92 inches squared. Does that look right? We'll take that. Part 2 for the cone is also just a lateral area. The perimeter of our base is going to be the same, 25.12, but we need to know the slant. That slant is going to come from Yes. 9 squared plus 4 squared equals the slant squared, so it's the square root of 9 squared plus 4 squared, which is what? 9.85 inches. So that lateral area is that perimeter of 25.12 inches times the slant of 9.85 inches. What am I forgetting yet? But by 2, because it is a triangle. Giving us 123.70 square inches for the cone. The sphere, of course, is just a sphere. It's half a sphere, so its area is 4 times pi times the radius, which is 4, squared, and we're dividing by 2 because it is only half a sphere. So 100.48 I'm getting there. No, for surface area, it should be just squared, radius squared. 4 pi radius squared. So we add all this stuff up. (626.10 inches squared for the total surface area. What do you think? Just had the formula off in your notes. Any major questions? Yeah? All right, so for volume, this part was the cylinder up here. So you find the area of the base, which is just that circle on the end of the cylinder. So you find area of the circle, that's just that area times that 16 inches to the other base. You would call it a height, it's just the distance between the bases is all. Okay. And then for the cone, it's the area of that base again, times the height, but it's divided by 3 because it's a cone. And then for a sphere, that's the area for the volume of a sphere, but we divided by 2 because it was only half. Yes. 16 from 20 gave us a 4-inch radius. That, yeah. Radius to the third. Yes. Okay, you switched them. Let's say that this object is being machined out of a material that has a density of 1.2 pounds per cubic inch. What's it going to weigh? Now, we have done one thing you should see with this. 1.2 pounds per cubic inch can be thought of as an equivalency. We can think of it as 1.2 pounds equals 1 cubic inch. That's just like saying there's 12 inches per foot. 12 inches equals 1 foot. So I can use this just as a measurement conversion. I don't need to know anything about density or its formulas. I just need to know that's an equivalency. I am starting with a volume of 1,088.53 cubic inches. I'll put that over 1. I want to convert it into pounds. So cubic inches go on bottom, pounds go on top. 1 cubic inch, 1.2 pounds. So the inches cancel. And yeah, we get 1,088.53. 1,306.24. You got it. That's what that weighs. Technically, we should be saying mass, but when we use standard units, we use weight instead of mass for some reason. 1 point, yeah, that's some dense stuff. Usually you're looking at about 0.6, 0.7 pounds per cubic inch. Lead. I'm not totally sure offhand. Don't memorized. If you look it up online, it'll most likely give it to you as, grams per cubic centimeter or something like that. If you get that, grams per, somebody look that up quick. Okay, so we get that 19.32 grams per cubic centimeter. What that is saying, 19.32 grams over 1 cubic centimeter. I'm getting a couple of days ahead of ourselves here, but that's okay. What's that going to be in pounds per cubic inch? Well, what I'm going to do is this. First thing I'm going to do is I'm going to do a quick conversion. I'm going to change grams to kilograms. Because I don't have a direct relationship between grams and pounds. Well, on your sheet, do you have one? It's actually in the back of your book. I didn't give you a sheet. In the back of your textbook, big textbook, yes. Yeah, you got that big conversion table? 829, there you go. So we don't need to convert to kilograms. We can do this directly. It would be, yes. But we've got a relationship between grams and pounds. 1 pound is how many grams? Like 453 or something like that. Was it 0.4536? 454 is what they're saying then. So 1 pound is about 454 grams. So let's change the grams for pounds. Next, we need to change the centimeters cubed to inches cubed. Now, 1 cubic inch, 1 centimeter is, or 1 inch is 2.54 centimeters. 1 cubic inch is going to be 2.54 cubed, or 16.387. Yeah. 2 or 3 digits, yeah. So now what I have is on top here, I have 19.32 times 16.387. Which is 316.597, we'll go. And that is pounds on top. And on bottom, we've got 454 cubic inches. So we're going to divide that out. 0.697. So about 0.7 pounds per cubic inch is what we're looking at for gold. Somebody look up lead. I'm going to show you a neat little trick here. Grams per cubic centimeter. Yeah. A lot of people think lead is like heavier than gold. It's not. So we've got 11.34 grams per cubic centimeter compared to 19.32 grams per cubic centimeter. The gold was 0.697 pounds per cubic inch. So what's that going to mean for our lead, we're just going to cross multiply and divide. So take our 0.697 times 11.34 divided by 19.32, and we get our 0.409 pounds per cubic inch. Well, I got good news for you.